In this video, I'd like to talk about how to factor using polynomial division. And in all of these example problems, we're going to be given some polynomial where we know one of the factors. And remember, a factor just means that it's going to divide evenly into our polynomial here. So we can use that information, we can divide it into our polynomial to figure out the rest of the factors. And each of these factors will look like this one. It will be linear, where x in this factor is going to be raised to the first power. So another way to think about this is that basically we have x plus 3 multiplied by some polynomial. I'll call it, let's say, q of x. And this will be equal to our polynomial p of x. So to figure out what this smaller polynomial expression is, so that we can further factor that, we can divide each side of this equation by that known factor, x plus 3. And by doing that, we would get our missing polynomial here. And again, it's going to be a smaller polynomial than p of x. In fact, in this case, it will be some quadratic polynomial since we have degree 3 and we're basically going to be dividing by degree 1. But we end up with this missing polynomial by taking our given polynomial and dividing it by our known factor. And this is where long division of polynomials will come into play. So let's set up our problem. For this specific one, we're going to take our polynomial p of x, this 2x cubed minus x squared minus 25x minus 12, this third degree polynomial, and we'll divide it by this linear factor, x plus 3. So let's do that over here. Let me change colors. And when we divide this, like I mentioned, what we're going to do is use polynomial long division. So let's set that up. We're going to put x plus 3 on the outside since that's the number dividing into the polynomial. And we'll put 2x cubed minus x squared minus 25x minus 12 on the inside. And we don't have to fill in any of the missing terms since we have every term. Notice 3, 2, 1, and then technically you could write x to the 0 there, but we usually don't do that since that's just 1. And now that I've made a little bit of room, let's jump into this division problem. So we need to determine what would we multiply x by to get 2x to the third power. And we can multiply this by 2x squared. So now let's multiply this 2x squared by our linear expression here to be able to figure out the remainder. So 2x squared times x, that's 2x to the third. 2x squared times 3 would be plus 6x squared. And now, as always with division, to find the remainder, you will subtract. And the first terms, if you're doing it correctly, these always cancel out. So we get 0 x cubes. And we have minus x squared minus 6x squared. So that's minus 7x squared. And if you've seen my video on polynomial long division, I always recommend putting this in parentheses to remind yourself that you're subtracting the whole thing and to help recognize that you need to distribute this negative to each of the terms. So this just helps you keep your signs in order. Now, once you find the remainder, then you bring down the next term and repeat the process. So we'll bring down the minus 25x. Let me just move over so we have some more room to finish this and scroll down just a bit. Now, like I said, we're just going to repeat the process. And we need to ask, what do we multiply x by to get minus 7x squared? We can multiply by minus 7x. So now to find the remainder, we multiply this by our linear expression here. So minus 7x times x is minus 7x squared, which is what we're looking for. And minus 7x times 3 would be minus 21x. And now we subtract to find the remainder. And you can see the advantage of using parentheses because there are a lot of negative signs here. So the first terms, we have minus 7x squared minus negative 7x squared. So adding 7x squared since we're subtracting a negative. So that's 0 like we hoped for. And we have minus 25x minus negative 21x. So that's really adding 21x. And so you get minus 4x. And after finding the remainder, we bring down the next number and repeat the process once more. So now, what do we multiply x by to get minus 4x? Well, we multiply by negative 4. And just so that we know what we're looking for, we should end up with no remainder in the end because we know x plus 3 is a known factor of this. So it should divide in evenly. In fact, if you do get some remainder, that's a clue that you're making some mistake. So now let's find that remainder. We're going to multiply this by negative 4. So that's minus 4x, and negative 4 times 3 is negative 12. And notice we are subtracting something from itself, essentially. So minus 4x plus 4x is 0. And minus 12 plus 12 is 0. Since we're subtracting a negative, that's just adding. And so our remainder is 0, which is what we expected or what we hoped for. So that's a clue that we're on the right track. So essentially what we figured out is that when we divide this polynomial, this p of x, by our known factor, we get 2x squared minus 7x minus 4. And we're not quite finished because we want to rewrite our polynomial as a product of linear factors. And so if we just rewrote this, our p of x, as x plus 3 times by this quadratic, this is not a linear factor. So we need to further factor this quadratic. So we're not quite finished, so let's continue that problem. And to factor this, let me just make this note that now we will factor 2x squared minus 7x minus 4. We're going to have to use the grouping method because our coefficient on x squared is not 1. So remember, grouping, we're looking to break up this minus 7x into two different terms. We'll call them ax and bx, where the coefficients of these terms with x in it are going to add up to negative 7. Essentially, we're just breaking this up into two different things, like maybe minus 3x minus 4x. So that's one condition. The other condition is a little bit harder to remember since it's not quite as obvious, but it is true that a and b, these two coefficients, are going to multiply to the product of our coefficient on x squared and our constant term. So in this case, 2 and negative 4. So we're looking for two numbers that add to negative 7 and multiply to negative 8. So you can write out a list of this if you're not sure, because sometimes these numbers get big. So let's look at that. Minus 8, we want to look at its factors. Could be minus 1 and 8, 1 and minus 8. And honestly, the numbers might jump out at you right away, but sometimes, like I said, they're not obvious. And when they're not obvious, just write out the list of all the known factors of whatever your numbers are going to multiply to. So we can do 2 and negative 4, or negative 2 and 4, and those are all the known factors of negative 8. And we need them to add to negative 7, so that would be 1 and negative 8. So let's continue with this factorization here. So this is now equal to 2x squared, and it doesn't matter which one you put first, so let's just do plus 1x minus 8x, and we have minus 4. Now we're going to use grouping. We're going to group the first two together and the last two together. And like I said, if you put the 1x here and the minus 8x here, it would still work. And when you group, we're going to pull out the greatest common factor from each of these pairs that we grouped together. So let's pull out an x here. And we're left with a 2x plus 1. And since all of this is positive, I'm going to pull out a negative here. Since if you don't pull out the negative in your greatest common factor, you're going to end up with the opposite of this on the inside of these parentheses. So I'm going to pull out, looks like negative 4. And here we're left with a 2x, and here we're left with plus 1. Like I said, if you didn't pull out the negative, you'd have minus 2x minus 1 here, which is the opposite of that. And to know that you're doing this correctly, you want each expression in parentheses to be the same thing. Now, to finish this problem, we need to factor out the greatest common factor from each of these terms. And notice that they share the 2x plus 1 in common. So we'll pull that out, we'll factor out that 2x plus 1, and we're left with an x here, and a minus 4 here. So we've transformed this quadratic into a product of linear factors, which is exactly what we want. So now we can finish the problem. So 2x, let me just write it up here so we can see it. This is 2x plus 1 times x minus 4. And now let's scroll over, look back at our problem. And we know that x plus 3 is already one of the linear factors. And the other two we found are 2x plus 1 times x minus 4. So this will finish off our problem. Now, if you really want to check your work, just to double check that everything is correct, you just want to re-multiply everything out. So first, maybe multiply these two binomials. You'll get some quadratic, and then multiply that by this binomial here. And if you did everything correctly, you should end up with your starting polynomial.